Hi and welcome to this tutorial. We are going to start a basic DSP framework, digital signal processing. So basically we're going to, within Supercollider, make an effects processing unit, essentially. If your guitar is like basically in a guitar's pedal board with multiple effects, or for any really instrument, we're going to focus a little bit on designing the effects. But at least in this first set of tutorials, we're going to create the necessary coding framework within Supercollider to allow you some flexibility to use different ins to a certain degree, but also just change between different effects. And maybe eventually look into creating a GUI that will allow you to switch effects, and then also maybe hook up some external Arduino devices so you have some options for pedals or switches, etc., etc. Okay, but in this initial tutorial, I want to cover a couple different ways of working within Supercollider that are a bit new to followers up to this point, or to the videos up to this point. A bit different from those techniques practiced before. The first thing I want to just introduce is a way of launching everything in Supercollider all at one time. Oftentimes, since Supercollider is a real-time environment, you're having to evaluate certain chunks of code over a period of time. In this way, I'm going to create kind of a function or just a one chunk of code that I can time the way it's launched, but also allow me to use variables in a slightly different way, because I'm not going to use global variables either. Okay, so why don't I go ahead and do that. First, I'm going to start with a set of parentheses, so I can just open and close everything all at the same time by one command return. And then what I'm going to do is I'm going to do s.wait for boot, and those have curly brackets to declare its scope. So I'm going to do that. So that means that whatever code is run inside here, it's going to boot first, wait for it to complete booting, and then run all the code inside the curly brackets. And then finally, I'm going to do a fork, and then again, it has its own scope, a set of curly brackets as well. And what fork does is it launches it starts a routine, what's known as a routine. And the main advantage that I want to gain from doing things this way is that I can put some timings in. I can use this function. I can do 0.1.wait within a fork, and so it'll run something, it'll do something, and it'll wait a certain amount of time to do something else. So for example, sometimes you need to add some synth defs, and then you need to start some synths based on those synth defs. Well, if you do it all in the same go, those synth defs will not have been loaded yet. Sometimes when you're loading buffers too, you do the same thing. You want to load up the buffers and then use them. In this way, you can wait a little bit, pause between the two, and just do it all in one go, a bit like how processing is run. So this is one way of doing things. Obviously, there's a lot of advantage in Supercollider to having these real-time where you can re-execute blocks of code, and that's very handy. In this case, I'm just going to kind of do things this way just to show you a different way so you can run everything together. Okay, so that's a basic structure. Let's select all and go edit, auto indent, and nothing to auto indent, shove everything over. Okay, now what we can do here is within the fork, we can create just local variables, so we don't have to use that tilde notation. So we can create variables that are within here. And the advantage of this, I'm going to be very careful in developing the DSP framework so that these variables are not exposed to the outside. Because I could be working within this thing and then be working on some code in another page, and if I happen to use that same global variable, it's still in play, and I can eliminate some things that I've done here. Okay, so we can just do var for everything. If we go var a equals 1, for example, and then we'll say a plus a dot post ln. All right, so if we do that, and we do wait, we do 1.wait, and then we say we'll copy that line, a plus a post ln. Then we can run everything at once. We can recompile, for example, just put my cursor anywhere within this, command return, it'll run my thing, and it'll go 2 and then 3. Wait a little bit and then print 3. Okay, so there you go. So now we have eliminated the global variables, which are handy, but in this case I'm going to just keep them internal because I don't want them exposed to the rest of my Supercollider life. And then we have this fork that allows us to change the timing with which we launch things. We can launch everything at once, as well as boot our server all in one go. Okay, so that's just kind of the main starting change that we're going to do. And I'll get to the other one later after I establish a few things. Okay, so these are just sort of a structure here. We're just going to sort of ignore them. They make them invisible, not worry about those things, as long as we understand that that does that, and we can behave a little bit differently in the way we code things. Okay, so I'm going to save that. So what I would like is, I would like a digital signal processing. So I'd like an effects processing, essentially. So the first thing I would like to do is to have some ins. We're going to bring in microphones. Okay, so and I'll probably change the orders and do different things variously in different ways. Right now we're going to create a synth def, and we'll have it mic in. Okay, mic in, and we will create the function that it's going to be in, and we'll end it and .add. Okay, so basically what we want is a sound in that's going to be a mic, and we're going to throw it out to an audio bus, really. But right now, let's not worry about that, and I'll explain to you how we're going to do this. So let's just create a basic mic in synth def, create some args, and we want to know the in channel, so ICH, and we'll initially set that to 0. That'll be mic 1. And then we need to know the out bus, OBS, and that'll be initially just to the right speaker. Yeah, that's fine. Okay, and we'll have an amp, so we can control, we'll just say in amp, for example. Okay, and we'll just set that to 0.85. All right. Oh, well, we'll just set it to 1 for now. It's fine. Okay, and then there we'll have source. There. Okay, and our source will be a mic in, a sound in. So sound in grabs the first mic channel, different from in, which grabs grab a bus. It could grab audio from a private bus. Sound in will grab the first live mic channel coming from your sound card. Okay, and this will be the in channel. So whichever live mic, if we have an 8 channel in, 0 will be channel 1, 2, 1 will be channel 2, etc. Okay, so we're going to do sound in channel, and then we'll times it by the in amp. Okay, so then we can control the amplitude of our input, and then we just simply take that in from the mic and send it back out to our DAC. In some cases, it might go out to a private audio bus, so out.ar, and the bus will be OBS, and the thing we send out will be the source. Okay, so that's easy enough. That'll be our mic in synth def. Okay, so the idea now in our framework, why I'm calling this a DSP framework, because we're going to set it up a certain way. We have our mics in, and we'll have our effects. Okay, so a couple of things we need to do to make sure those things happen in the right order, and that it's kind of flexible enough for us to use as a system. One of the things we need to do is we need to set up some groups. Okay, so now remember, groups have to do with the order of the nodes, which is more of a coding or programming or a computational concept. So in other words, these are routines, or these are bits of code being run, and they have to be run in a certain order. Now, Supercollider gives you quite a bit of flexibility with a node system as to what order things are run in. Okay, but for example, if I want to bring something in on a mic, and then I want to send it out to an effect, I have to run the code that brings the mic source in first before I run the code that sends that source out. Otherwise, you won't hear any audio, because it'll do the effects processing first, and then it'll try to bring the mic signal in. So they'll be reversed. And an easy way to deal with that sort of coding order of operations is to use groups. Okay, and again, we can use just these scoped variables that are only good within. So we're going to create a var, and we're going to call it G0. That'll be our first group, and we're going to make a group .new. Okay, oops. And then we're going to make a var, and we'll call it in. Sorry, what would I call it? Did I call them G in or G0? Ah, we'll just call it G1, and I'll make it so there'll be an ins and an outs group essentially, and we can add more if you want. We'll see how that works, and we might have to add some more later. But well, let's see how that works for now. We'll have a group, and this will be dot after, and this will be after this G0. Okay, so we're going to create a group that starts after. So if we add something to this group, all these things will be run after all these things. Okay, so anything we add to group 0 will be run first, and then anything we add to group 1 will be run after the things that are run in group 0. All right. Now the other thing I want to introduce, so separate from this but very similar in logic, is I want to introduce a bus system, an audio and possibly later a control bus system. So what we're going to do is we're going to have some buses, private buses, where we send the audio to the buses and then we grab audio from those buses, much like the patch bay system you find in most studios. So for example, if we have our mic in, we're not going to actually send them out directly to the speakers. We're going to bring our mics in, send them out to a patch bay, a virtual patch bay, and then in the form of buses, and then we're going to use those any of our effects or something to grab audio from that patch bay. Then we'll patch them into the patch bay from whatever mic we want to patch, and then patch it into whatever channel out speaker we want to do that. All right. So we're going to create an array of channels, depending on how many you want. So I'll just, for demonstration's sake, create 2 mics. Pretend you have 2 performers, for example, but in most cases you'll probably do 1. So we'll call it a var, and we'll call it what did I call it? AB for audio buses. Let me be a little bit more explicit. So BUSSES buses audio, something like that. That's good enough. Equals, then we're going to create a bus, and then we'll use this array notation, this exclamation point, which just multiplies it. So we're gonna, but we have to put buses and things like buffers and stuff have to go in a function. Well, just you'll see it, and then I think it'll be understandable enough. So we're gonna in the function put a bus dot audio. Okay, and then it just takes the arguments of server, number of channels, which is 1. We can just leave that at default, but that's fine. And then encapsulate that in a function. I guess what happens is if you don't put it in a function, oh well, let me show you the rest of the syntax. And the multiple exclamation point will create an array with this amount of that. So in this case, we have 2 channels. So basically, it'll create this amount of these things on the other side of the exclamation point and stick them in an array. Okay. If we were to not put the function, the curly brackets, you would create the same bus. We want a different bus, so we would create bus number. Let's say it signs it bus number 1, so that it would create 2 bus number 1s. Okay. In this case, within the function, it creates a bus number 1 and a bus number 2, 2 different bus numbers. All right. So that will be our I don't know that I want to call it audio buses. I want to call them in bus. Okay, I'll just call it in bus. I'll call it mic bus. Okay, we'll call mic buses or mic bus 0, mic bus 1. Now we'll have our 2 channels of audio. Okay, so so now we get to our thing. So if we want to just set up our mics, we have the 2 groups, which you'll see we'll use a little bit more later. It'll become more explicit how we use them. And we have our buses that we're going to use here. Okay, so what we want to do now, and then we get to see a little bit the second concept, which is the idea of node messaging or server messaging. Okay, which I'll explain more. Don't worry about that. Title, right? So what we want to do first, at least in our order of operations, we want to load up all our synth-defs, and then we want to start some mic in synths. Okay, so we'll go ahead and do that. What we're going to do is we're going to create a couple synths to bring our mic channels in, but we're going to have a little wait here. So we're going to 0.1 dot wait. That's probably far too long, but that's fine. We're just going to give it a little bit of time to load the synth def, and then start a synth. Okay, so we're going to keep our mics in an array as well. Okay, so we're going to create another var. And we'll just keep doing this. We're going to have a whole big slew of variables by the end of this. And we'll say mics. Or just say mic like that, because we'll have like a mic 1, mic 2. Okay, and we'll just create an empty array, and then we'll initialize them later on after we load our synth defs. So it'll be an array dot new clear, and its amount will be 2. And of course we change that depending on the number of channels. So actually, if you want to go ahead and do that, maybe it will be wise to just make it all variable. So num num mics equals 2, and then we'll just slot that in here. So it'll be, we'll create that many buses for the number of mics, and we'll create that many empty or an empty array with that many slots for the number of mics. Okay, and then when we're actually creating the synths, we'll just go right, sorry, excuse me. I am doing this a completely different way, right? So I wanted to show you that new method. So we actually don't need any of this. Okay. So, but we'll create that. Maybe not. Okay. So in any case, no, it's fine. Well, let's keep this. Except we're not going to make an array. We're going to make, say, we'll say num. Okay, mic number. Okay, because we're going to use this. The second new thing that I'm doing is I'm introducing the server messaging or node messaging, right? And that is just slightly more reliable, so we can deal with a specific entity on our server, a node known as a node, and we can kill it or create it and free it, and it can't be replaced. So in the old way of using global variables, you'd create a synth and maybe try to create that synth again, and so you'd have multiple versions of that synth sitting on your server. But some of them now, because they were assigned to the same global variable, can't be accessed. So you'd have things running that you can't get to. You'd have to kill everything to get to. This way, it just makes sure you're dealing with one and one entity only. And it's just a different way of interacting with a server, which is interesting as well. Because if you do pure server messaging, you can get rid of the client altogether. So you don't have the code within this. You can use other programs to send the Supercollider server these specific OSC messages. Okay. So actually, we want our we'll call them indexes. So we'll say I for initial mic index, ID X, initial mic index. I suppose we can use capitals to make it a little bit more clear. Okay, initial mic index will be, let's start, because it starts at 1000 for the original things. So let's just start those at 2000. Okay, that'll be the initial node. Okay, initial mic index. Okay. Now what we're going to do is we're going to use this node messaging. Okay, so let me show you that real quick, and then I'll pop it in for the multiple mics. So normally to create this mic in synth, we'd say give it some variable, say tilde a, and we'd say equals a synth, and then we call the synth name mic in. Okay, and then we'd have an array of various arguments. So we'd have to maybe establish that the ICH would be 0, the in channel, and maybe establish that the out bus would be one of these private buses, which would be mic bus 0, okay, for example. And in amp, if we want to change that, we could do that as well. And then if we close that and close that, that's how we would declare our mic in synth. And if we ran that, we'd have a synth, and then our mic would come into this private bus, and then eventually we can grab sound from that, like the patch bay. We can patch into that microphone if we wanted to with one of our effects. Okay, but instead I'm going to propose that we use a different kind of node messaging, and then I'll go through each of these steps in the new format. But let me copy it over. I think I have something that spells out all the things. Maybe not. Okay, well, let's grab that, and I'll talk you through them. Okay, so instead we're going to use what's known as node messaging. Now you can look this up in the help file if you search for server command reference, for example. Server command reference, there, and it tells you about it. Also, node messaging. that will explain. But basically, already as just the way Supercollider is built, the language side, what we're programming in here, or the client side, the language side, communicates with the server via OSC messages already. So if you had a remote client or something like that, and you want to communicate with a server on another computer, you can do so using OSC messaging, or from another program, as long as you use the proper syntax. Okay, so we're going to start with to do this, to do what we have here, we'll start with the s.send message. So s is already the net address of the server, okay, and it just presumes your local host, and your local host 57110 and 57120 is the client side port number, 57110 is the server side. So it just presumes that already. So you already have that set when you run Supercollider, and we're going to send s, the server, a message. Okay, so that's what we're going to do, and the message will be in there. Oops, with a semicolon. Now, it has certain built-in addresses that's looking for, or it's waiting to receive OSC addresses. So one is s new, and you'll find this in that server command reference. So s new will create a new synth, okay, and then it's looking. The next argument will be looking for its the synth def it's based on, which is mic in, just like over here. Okay. Now the next one now, and that's why we went through the trouble of having this initial mic index, is it's looking for the node to which to start on. Okay, so it's looking for the node. All right. So we'll create this to be on the initial mic index. Okay, 2000. So we'll say I mic IDX. So that will start on node 2000, and that's the particular thing. So if we create a node at 2000, we can kill that node at 2000. If we try to create it again, if we try to make another thing at node 2000, let's say, can't do it, that's a duplicate node, or we can replace it, but we can't have two of them. So in this case, we'll only have the one mic at that node at 2000, and then when we go to kill it, it'll be dead. If we try to create another one, it won't replace it and have multiple versions of this synth on that we don't know where things are. So things are a little bit more controlled in this context. Okay, so we're going to create add a specific node. 0 is a type of action that you add. So if you look at the node messaging server command reference, that's better. Okay, and if we look at s where is it? s.new, right? Okay, and it says add action. This is where these are all the arguments. This is where I'm getting this from. And there's add actions. If it's a 0, you're just going to add to the head of the group. If it's a 1, you're going to add to the tail of the group. If it's a node, to just the node specified, etc., etc. There's a number of different actions. Happy enough with a 0, so we're just going to add it to the head of the group, which is fine. That's no problem. We already have groups that will sort things out. We don't worry about where in the group it's being added. Okay, so that's what that 0 represents. And then now we're going to add it to the target, or the group that we want to. So the main difference that could get you into trouble too, that we have to just be completely aware of, is things have to be a little bit more explicit in node messaging. So in other words, I can't just put the group name there or the group thing. I have to do .node ID. I have to say I want that group's ID number. Okay, its actual node number, it needs to go there, not just a group. If I was to do it here, asynth and add it to group, I can just do, which in this case is not tilde G0, but just G0. I can do G0. Okay, but that won't fly here in the node messaging. We have to actually explicitly say we want the node ID of that group. So we're going to say G0.node ID. Okay, so we're adding this mic into the 0 group, the G0 group. So those are our ins group. So the computer knows that it needs to run all the code for mic ins before it does any out or does any processing. Okay, so it's going to run it's going to get all the audio in, and then it's going to run the processing code, which will be on G1, for example. Okay. Now the next bit will be, now after that, we're done with the more esoteric stuff, and it's just be the list of arguments. All right. So for example, let me just shrink this a little bit for now. For example, we're going to replicate this in channel. So ICH will be 0, which will be our mic, the first mic. Okay, and then let me just make a hard return so you can see. Then the next, just a list of arguments now. So the OBS out bus. Now again, this is a part where it could catch you a little bit off, so just take this to heart, because I've made a lot of mistakes and they're very, very hard to find. But now that we want to send it to this mic bus, we're going to send it out to a private bus like a patch bay, right? And then we'll pick it up from that patch bay from our effect, so that we can change the effect on the fly. Okay, and then we set up these buses, audio buses, under mic bus. Okay, so we want to send it to mic bus 0, because this is mic 0. So I'm going to send a mic bus, which is an audio bus 0. Okay, but this node messaging is going to balk at that, because it can't send it to a bus. It needs to know its actual number. And in this, for buses, you're going to do index, INDEX. Okay, so that's going to be the actual index of a bus. It's looking for a number there, right? Okay. So then I think that's it, the out bus. Okay, so we have all our arguments there. Let me shrink it even more so we can get it all in one line. It might be a little hard to see. Oops. Oh, because I did a hard return. Okay. But anyways, that's that. We can get rid of that. That's just our example. Okay, so one more. So this is this send message is a duplicate of this synth creation line, a equals synth, mic in, etc., and then that list of arguments, and adding it to group 0. In the node messaging format, you're going to send an OSC message to the server, which is always S, and then you're going to send the OSC address or the OSC name s_new, and notice that it's that /, which is okay, I guess, in SC lang. Normally it's backward slash. Normally it's a /. Then you'd put that in quotes. And I think that might even work, but we'll just keep it this way anyways. And then we're going to send mic in. That's the synth it's based on, the synth def. And then we were going to create it at a specific node. So it's contingent that in our code that we just keep track of these nodes. When we're killing it, when we're starting it, we'll always have to do it at that node 2000. Okay, so but that will be very specific, so very controlled. So we can kill it, we can start it, we can change it. Always dealing with 2000. If we try to replace it, it won't let us. Okay, this is the add action, which will always be 0. We're just adding to the head of the group. We're not going to worry about where it goes. The G0 node ID is the group we're adding it to, which is the group we created here for the ins, the G0. And so that means all our computing for G0 will be done before any computing for G1. So if we have in mics or samples in or something like that, we'll make sure those are all done first before we add any effects on that. All right. And then a list of arguments which are specific to the synth def. So in this case, either in channel, out bus, or the amp if we want to change it on creation. So we're going to do in channel 0, OBS, and then again, taking a lot of care to make sure that we're very explicit about things like node ID and index, and then also buffers will have their own thing. It will be buff number. Okay, so this bus, but we want its index number, not index. Okay, otherwise it'll balk. Okay, so this does exactly what this does. Okay, so that line does what that line. It's just a different format, and will be helpful in the amount of control we have over that particular node, which will be that ID with 2000. Okay, so let's get rid of that line because that's doing that, and we could make a little comment. We'll say create mic in synth. Okay, and now I'm going to do this basically what I've done, except I'm going to make it so that it's variable your number of mics in. So if we have 2 mics in, we're going to make it so that it does something that's variable. Okay, so we'll do a do. We'll do a for loop, or in Supercollider you do x.do. So we do a num mics dot do, right? Okay, and then we'll have the open scope and the end scope like that. And then the first, if it's an array that you're doing the loop on, you have 2 variables. But if it's just a number, an amount, then you have the first argument is your index number. It just iterate through. So if it's 2, ix will be 0 and then 1, and then that's it. Okay. So then what we're going to do is we're going to create 2 one for each of the mics, right? And we just have to make a few of these things variable. So this iMic index will be that plus the IX, the variable. So we'll create a node 2000 plus 0, so it's 2000 initial mic index, and IX will be 0 for the first one, so there'll be one at 2000, and then there will be one at 2001, because when IX is equal to 1, iMic index is 2000, so 2001. So there'll be two nodes, one at 2000, one at 2001. All right? These are all the same. The group is fine, and the same group. In channel, we're going to change that, right? Because if we're getting the first player from mic 1, or mic 0, the first mic, we're going to get the second player from mic 1. Sorry. So that's going to be IX. So it'll be either 0 or 1, right? And then the out bus will be one of the mic buses. We set up two here, mic bus, and we did this array. We made an array of them for the number of mics. So there's two of them there, two of these audio buses. And so we'll change that to IX as well. Okay, so then this way in this one do loop. So if we change that to 5, it would automatically create 5 synths, mic in synths, and it would just push them over. So it would create a new node number, unique one for each one. And that's why we have to keep track of these initial numbers so that we don't put anything else on the 2000. And then it will, it will add them to the in channel 0 through 5 or whatever, 0 through 4. And then put them out to a private bus. Now remember, this is not going out to a speaker. It's just going out to a private audio bus, like a patch bay, from which we'll pick up that signal in. Okay, so let me shrink this so you can see the whole thing. Oops. How it is. Okay, number of mics due. IX will be iterate through the number of mics 0. If it's 2, it's 0 and 1. And then create a new synth send message at one line. Every time it's run, we'll create a new synth based on this mic in. And it will just update the in channel, update the bus it's going to, update its node number, okay, to a different thing. So we can put that all on one line if we want to, since it's just fairly simple code. It's just a one-liner, so we don't have like that. And also, I realize I'm using this notation right here. That is the same thing as arg ix, like that. Okay, it's just a shorthand. So these two lines just make, that's your list of arguments. And then when you're listing several arguments, you don't even have to put commas in between, just a space. So if you have it and A and B and C, like that. Just a little bit of shorthand. Okay, and then at the end of it all, we're going to need a semicolon to end that line. Okay, so great. So I'm going to end this video here, but basically we're getting started with our basic framework, and we're really getting there. I've introduced two kind of new concepts, and I've gone over those in a fair bit of detail. One being this kind of all at once run setup. We're going to boot our server, wait for it to boot. We're going to use this fork, or in other words, create a routine, and it's going to allow us to use these these little pauses in the way our code is run, so that we can send a bunch of synth-defs and then actually create synths based on the synth-defs all in one go. And the second concept I introduced at quite a bit of length, is this node messaging. And that's going to give us a little bit more control when we get into starting and stopping synths and effects and such like that. It'll be very helpful. So we're not, I guess it's a little bit more robust, so if you're sitting there in live performance and you're processing these different effects, you're not going to accidentally send effects twice and then have one sort of lost in the ether that's continuously going, a distortion effect that won't shut off or something like that. So this node messaging is helpful. So it's just a question of sort of learning it, which is not too different from the normal way of doing things. It's just we have to remember to be very explicit, use things like node ID or index or .buffnum when we get to buffers. When we're very explicit, because it's looking for numbers, and then we just have to understand the few extra bits of arguments, being the actual node, an add action, and various other things. Okay, well, let me just very quickly, we can tidy up our code here and say this is the end of the fork, and here, because it'll get pretty long, this is the end, s.wait for boot. Okay, so hopefully that's helpful to you, and in part 2 we'll continue on with creating our DSP framework.